25 or 30 years ago. So I would like to mention that these are not something new technology, but the technology advancement in IC design create the AI wave these days. Without in Chinese, 算力, okay, hardware computation power, we don't have an AI these days. Okay, so I would like to let you know the underlying technology that enable AI is all these chips and ICs and FPGAs and so on. So the topic itself today is very important. Okay, so that's why I want you guys to do your best. Nat, you want to say something? I see that you are unmuting yourself. Okay, if not, please mute yourself. Okay, so I want to mention that the topic itself is very important. But if you want to learn more, keep doing it. I know Peter has a foundation, and also he's doing his PhD, and this is very important that enable you for a bright career. But do not work on the superficial material because those are the easy part. Easy part do not have the value. Go for the difficult part that can bring you value. And I like to stop here. I want to put the time forward, and I believe you're going to learn a lot from Michelle. And we start from small. I see Yahon just arrived. He missed my speech, and I didn't prepare my speech, but I think these are all very important message. I hope you all can do the best. So Peter, I pass the time to you, and you can lead the session with Michelle. Thank you.
Okay, very thank you, Professor Wei, for giving me a talk. And I think Professor Wei is very hands-on and have passion guy. So, Michelle, can you start your presentation?
Okay. Hi everyone, and
you share your screen first.
Oh, okay, sorry. Can everyone see the screen?
Okay, we can see it. We can see it.
Good job, Michelle. Go ahead.
Okay. Hi everyone, I'm Michelle, and today I'm going to share about the logic simulator to all of you. And this is our team, and we're all working on the same project recently. The reason why we're going for this project is we got some inspiration from the logic sim, and so we would like to create a logic simulator with advanced components and simulation skills. And this project is sponsored by Australian Computer Society and RMIT University. First of all, I would like to share the components of our logic simulator to all of you. And we allowed users to change orientations for all components, which can facilitate users to build their circuit diagram very easily. And now I will talk about the basics. First of all, we include pin. Like, we can allow users to change the data bits, which can cater different scenarios in a logic circuit. And there are different choices of radix, like binary, decimal, and hexadecimal, so that users can fit their design. One of the features is the tunnel, and it can transmit the signal through the tunnel. Like, every signals can be transmitted instantly, even they are far apart, just like the one here connected to the pin, and the other tunnel is connected to the LED. Even though they are not connected together, they can still transmit the signal instantly. And next, it is the splitter and combiner. And for the splitter, it is a 4-bit input pin, which can split into four 1-bit output pin to facilitate the circuit building. And it also works for the combiner, and the combiner works for combining a 4 1-bit pin into 1 4-bit output pin to facilitate the circuit building. This is the dip switch, and like users can choose the appropriate amount of switch in one go so that they do not need to create many pins in the diagram and to facilitate. Next, we'll move on to the output. The most frequent use of the outputs will be like LED, RGB LED, and LED bar. And the LED output devices that will allow users to show their output. For example, for the RGB LED, users can display different cards by controlling it with the 3 input pins. And for the LED bar, users can choose the amount of bars accordingly, just like the dip switch just now. Next, for the X7 display, we can display the 8 bits inputs, which default red color for on and gray for off. We can create it by showing different numbers with this component. And here is the example. Like we can create a big haircut, and it is a final sequential minimal SOP, and it will show the different numbers on the display. Next is the hexadecimal display. It looks like the X7 display, but it works differently. And this displays the hexadecimal digit corresponding to the 4 bits inputs, just like here. As you can see from the video, we can change the amount, the value by changing the hexadecimal through the pin, and it will display through the hex display. And the dot at the bottom represents the decimal point if necessary. Next, we move on to the TTY, and this component receives a sequence of ASCII code and display the printable character. Users can display the screen by connecting a pin to the clear input, and it will show the things on the right side of the TTY. And this is the video of for the demo. As you can see, I'm changing the ASCII code, and it will show the different characters on the right side. Next, we move on to the gates. And the most basic logic gates has like AND gates, NAND gates, OR gates, NOR gates, XOR, XNOR, or NOT and buffer. These are most basic components that we need to use them to build a circuit. Furthermore, we got the components like tri-state buffer and tri-state not buffer. And it's not only control its states like the basic buffer, it is also controlled by the enable pin here. Next, we move on to the plexers. First of all, I will introduce the multiplexer and demultiplexer. The multiplexer can choose which value to be transferred to the output by controlling the selected input. And for the demultiplexer, it can transmit several data through a single transmission line. And Both of the components can be controlled by the enable. Next, we move on to the encoder and decoder. And for the encoder, it can convert a set of binary inputs into a unique binary code as the output, to show the position of the input. And for the decoder, you can transmit the ones on exactly one output, which depends on the value received from the input. And these two components can also be controlled by the enable input or output. Next, we move on to another session for the arithmetic. I will introduce the adder and subtractor. And for the adder, it adds the two inputs value and outputs it sums at the output. And for the subtractor, it subtracts the two input values and outputs its difference at the output. And for B represents borrow and C represents carry. Our logic simulator also supports flip-flops, and like those flip-flops, JK flip-flop, T flip-flop, D flip-flop, SR flip-flop, and it's used to store the binary data, and the stored data can be changed by varying the inputs. And last, I will introduce the RAM, and the circuit can load and store values in the RAM, and our RAM can have different pages that can show every data on it. So now I'll pass the mic to Ken to introduce examples and demo to you.
Hello, I'm Ken, and let me share the screen for demonstration.
Okay, are we going to demo the logic simulator?
Yes. Can you see my screen now?
Yes, but your voice is very small. Can you say louder?
Oh, okay. Is it okay now?
Okay.
Okay. Can you guys see the
Yes, I can.
see the Arduino board?
Yes, I can see.
Everything. See that the pin is connecting to the pin 2 of Arduino, and the knob of the pin is connected to pin 4, and we can see the white light is representing for pin 2, and blue LED is for 4, red is for 5, and the green is for 18. And here is, and pin 18 is connected to this button. As we can see that when I press the button, the pin 18 in the Arduino is on. Can you guys see that? And when I press both buttons, the simulator will receive the data, and the engage is sending data to pin 5 of the Arduino board, so that the white light is.
其實你可以講翻廣東話啦，因為得個英文係。
走咗。好，咁大家會見到啦，我同時撳兩個掣嘅時候，咁個 simulator 上面就會見到engage 個 output 係着咗嘅，咁就會連翻去個 Arduino board 嘅 pin 5，即係紅色燈，大家見唔見到？係啦。咁我淨係撳一個不停嘅時候，佢係唔會着嘅，因為佢哋連住咗佢個 engage。好。 咁我介紹下呢個 Arduino WiFi 點用啦。咁大家就會見到呢度有個名啦。呢個就係揀呢個 Arduino WiFi 嘅型號啦。咁如果上面冇 support 都唔緊要，因為可以撳 Add，跟住如果你想 specify 一個 pin for Arduino 嘅就可以打，例如我想要14嘅，咁就打落去就會有啦。咁至於呢個 address 咧，我哋就可以睇呢個 serial monitor 就跟住一撳 reset 咧，就可以見到佢呢個 connect 緊佢個 WiFi 啦，咁就會見到個 IP address。咁只要將呢個 IP address 打落嚟呢度就可以啦。但係要留意嘅係佢哋即係呢個 simulator 同埋個 Arduino 一定要連住同一個 WiFi，因為佢呢個係 based on WiFi 嘅 web server 嚟嘅。咁跟住我想做一個test counter 嘅 demonstration 啦。咁呢度就係呢個比較大型嘅 test counter 啦。咁就可以見到呢度不斷跳緊啦。咁呢個 circuit 就係用緊 NAND gate 啦、GK flip flop 啦，同埋 NOT gate LED 啊、pin 同 pop 同埋最重要嘅係我用咗呢個 module component 去縮細呢個 circuit 嘅 size， 大家可以見到呢度 AR2 啊、GFD 有第三個呢啲嘅，咁就可以縮細呢個 circuit 嘅 size。
阿 Ken 你係咪講完啦？
係，跟住而家去翻 PowerPoint 度啦。咁呢一個就係VCD 之前 VCD 個 component 嘅出嚟。咁我依家我講個 demo 完啦，我依家將時間交翻俾佢。跟住
好，咁佢哋 demo 完啦，咁而家就到我啦。咁我而家主要想咧就講下咧呢樣嘢嘅，就係講下 FPGA 嘅原理。我想問係咪大家都聽得我個咪好清楚啊？你聽得我個咪係咪好清楚？
聽到啊，聽到，好清楚。
好，咁我介紹下啦。咁我係香港編程學會嘅會長啦。咁我呢個 project 其實係 RMIT 學校 project。阿 Ken 你呢個嘅？咁我而家咧就係講下咧嗰個 FPGA 咧嘅結構嘅。咁其實咧呢個世界咧就有一樣嘢咧，就有兩種嘢都可以我嚟寫 program 嘅主要。第一種咧就係你用個 CPU 啦，即係你寫完個 program 俾 CPU 去溫。第二種咧，我哋叫佢做 programmable logic device。咁其實而咩叫 programmable logic device？即係簡單啲嚟講，你直接寫一啲邏輯嘅嘢，用一啲 AND 機、OR 機或者一啲嘅 flip flop 組成你要想組合嘅 program，然後將你個 program 咧燒落粒 chip 度，咁個 chip 咧就會根據你嘅要求咧喺度行㗎啦。咁呢啲叫做 programmable logic device，咁就 out of CPU 另外一種寫 program 嘅形態嚟嘅。咁咧 FPGA 咧，其實咧你等陣話俾你練先先。係啦，咁呢個世界咧就有幾種嘢咧都可以寫到 program 嘅。第一種咧就係就係 PMA， 第二種就係 FPGA 啦。咁其實 FPGA 咧佢講咩咧？佢就譬如你見到第二行 O 等於 AB 加 BC， 即係話你有一個 Boolean 嘅 algebra， 你想燒落粒 chip 度。咁其實下邊咧就係一個FPGA 嘅圖嘅，即係話你可以將呢個 formula 去到燒落咧 FPGA 度，但係實際嗰個操作係點，同埋咧嗰個 FPGA 裏邊究竟係裝有啲咩咧？咁而家就話俾你知啦。咁其實 FPGA 咧佢就係一粒晶片啦。咁呢粒晶片咧就好似左邊嗰幅圖咁樣，佢由三個主要嘅 component 組成嘅。第一個咧就係綠色嘅 component， 就係一啲嘅 I/O port。咁但係佢就唔係話一條 I/O port 突出嚟，你可以射啲電流入去，或者攞啲電流做 read write，佢就唔係咁簡單嘅。咁佢裏邊就有啲 logic 嘅。咁而 CLB 咧就係你嘅 logic 嘅戲肉啦，即係其實你個 logic 咧就係 burn 咗落去到個 CLB 裏邊。咁而個 CLB 咧就係由 LUT table 啦、flip flop 啦同埋乜晒去到組成。咁至於紅色嗰啲線咧就係第三個部分。就係 個 connection， 即係嗰啲 switch。咁有呢3個組成部分咧，就構成一粒 FPGA。咁你見到右邊咧嗰個圖咧係咩嚟咧？就係個 I/O， 即係話其實得個綠色得個 I/O pad 咧好複雜嘅，就好似右邊嗰幅圖。咁其實點解要玩個 I/O 咧玩到咁複雜咧？其實得個 I/O 咧，除咗去到做一啲你哋平時 CPU 嘅 GPIO， 即係輸入輸出嘅動作之外咧，佢亦都可以咧設定好多嘅功能嘅，例如可以set 呢個 pull up pull down resistor 啦，佢可以做 OE 嘅 enable 控制啦，佢可以做到其他唔同嘅 standard， 所以佢個 I/O board 咧就會好似左邊嗰個咁複雜，所以你見到咧其實佢係由一紮嘅pull up pull down 嘅 resistor 組成啦，有啲 transistor 裏邊控制佢究竟嗰個 port 究竟係而家係輸入定輸出啦，如此類推啦。咁其實咧 I/O 咧都好多種 standard 嘅，咁你見到呢個表咧就係其中一紮嘅 I/O 嘅 standard 啦。咁呢紮 standard 咧就係咩咧？就係佢有唔同嘅名嘅，譬如有啲 I/O 咧係去到驅動呢個摩打，有啲 I/O 咧係可能特別驅動LVDS 嘅。咁呢啲咧全部都係有個 standard 喺度嘅，例如 RAM 有 RAM 嘅 standard， 你個 I/O 要驅動咗做monitor 有 monitor 嘅 standard， 咁所以咧其實FPGA 嘅 I/O 咧都會比你哋想象中咧係複雜嘅。咁另外咧，除咗 FPGA 同 LUT 之外咧，佢有一啲叫做呢啲 switching board 嘅嘢，即係話你嗰個 FPGA 上邊咧有好多 CLB 啦，咁每個 CLB 就種嗰啲 logic 喺裏邊啦。咁但係啲 logic 同 logic 之間大家要互相 connect 先至可以行到噶嘛。咁佢就用呢啲咁嘅 switching board 去做。其實邏輯上嚟講咧，就好似左邊嗰幅圖咁樣，佢有個原點啊，即係代表兩條電線通咯；冇原點啊，即係條電線斷開就咁簡單。咁實際要做到呢個效果係點做咧？其實佢背後係用個 transistor 嚟做嘅，即係話如果個 transistor 就去控制佢通唔通電。如果佢通到電，佢咪可以好似個電線咁樣，代表個開關着咗咪通電，唔着咗唔通電啦。咁呢啲咧中文名叫浮棚。咁如果有興趣咧，因為呢個世界 implement 呢個咧其實有好多種方法嘅。咁如果有興趣可以繼續睇啦。咁而最重要嘅一樣嘢咧就叫 LUT。其實咧 FPGA 裏邊最基本嗰個單位咧唔係 LUT， 佢最基本嗰個單位咧叫做 logic element。一個 logic element 裏邊咧就會好似左邊咁樣包含咗個 LUT 啦，包含咗個 DP4 啦，同埋包含咗個 master。咁其實佢愛嚟做咩咧？即係話如果你呢個 logic element 愛嚟做 sequential logic 嘅時候，咁個 sequential logic 一定有 clock 噶嘛，佢就個 master 就會射咧上邊個 clock 啦。如果你 LUT 係做一啲 combinational 嘅 circuit， 即係話係冇時序性嘅，咁即係話唔使要個 flip-flop 啦，咁佢條路就經下邊嗰個 master 直接出到個 output， 所以 LUT 可以同一時間 simulate 到combination logic 同埋呢個 sequential logic。咁其實咧左邊嗰個咧，你留意到嘅 LUT 咧有4個 input 嘅。咁其實佢係咩嚟咧？就代表你個 truth table 有4個 input 一個 output， 你就可以自由定義究竟邊個 input 嘅 combination 係1，邊個 combination 係0。所以咧佢就可以實現到咧即係自由組合你個 logic 係點樣。咁同埋咧佢呢個 LUT 其實個實際係用咩做出嚟咧？其實有好多種方法嘅，但係最主流嗰種方法咧就係用條 RAM 做出嚟嘅。即係簡單啲嚟講 ，ABCD 就係你可以或者成為係條 RAM 嘅 input，Y 咧就係條 RAM 嘅 output。佢就用條 RAM 咧去到做呢個 LUT 出嚟，所以其實咧嗰個 FPGA 個 spec 嗰度咧成日寫自己有幾多 bit 嘅 RAM 咧，其實主要係愛嚟做呢樣嘢。咁究竟點樣先可以將我哋嘅 logic 咧拆解咗做呢個嘅LUT 咧？打陣話睇下先，係啦，佢咧就好似咧呢一個 logic 圖咁樣嘅，就係話譬如我有一個 logic。任何嘅 logic 咧，其實都可以用一個好特別嘅圖表去表示，就叫做 binary decision diagram。咁即係話咩咧？嗰啲1010咧就順序流落去，你就會見到咧想出嘅效果啦。咁呢個咧叫做 binary decision。咁我哋有咗呢個 binary decision 嘅時候咧，我哋就可以傾下咧，其實個 LUT 係點樣工作啦，就係。咁首先第一樣要介紹嘅咧就係嗰一種技術嘅，技術上邊咧就有3種嘅，咁我哋叫做 technology mapping 啦。咁呢個 technology mapping咧，其實就可以對應咗3種嘅技術嘅。第一種就係 ASIC， 即係話你要俾粒晶片出嚟就係 ASIC 啦。第二種咧就叫做 programmable array logic， 就叫 PAL。咁第三種咧就叫做 FPGA。每一種 technology mapping咧對應你嘅技術咧都係唔同。 第一種 technology mapping 咧就係 ASIC， 即係話 ASIC 係咩咧？就係你間廠想幫你 build up 出嚟，佢就會俾個 PDK file 你邊個 PDK file 咧就會形容間廠可以 build 到啲咩啦，譬如可以 build 到 AND 機、OR 機如此類推。咁你個 technology mapping 即係話將你個 Boolean logic 去到 match 成間廠提供嘅機。好多廠咧其實佢唔會提供 OR 機俾你，佢淨係會提供 AND 機俾你嘅。咁即係話咩咧？你要將你個 logic 咧就好似幅圖咁轉成 AND 機同埋 NOT 機啦。咁因為大部分廠咧 build 都係 build 同一樣嘅嘢，所以如果你有OR 機有咩機都好，你就要轉成 AND 機。咁呢個咧就係 ASIC 嘅其中一部分嘅 technology mapping。第二種類型嘅 technology mapping 咧就係 PAL 啦，即係話你個晶片喺邊咧已經有一個 prefix 嘅機嘅 setting。例如咧，你見到呢一個最典型咧就係一個 sum of product 嘅機啦，佢有呢個 NOT 機啦，有呢個 AND 機啦，同埋最後用 OR 機將啲 terms 咧就黐埋。咁你嗰個 technology mapping 即係話將你一啲自由整出嚟嘅機就轉成佢呢個模式嘅機，即係話等於咧將你個 Boolean logic 轉做 two level logic。咁然後咧，你就可以立到落去到個晶片嗰度啦。呢個就係 technology mapping。但係呢兩個咧都唔係我哋關心嘅嘢嘅。其實我哋今次咧係關心 FPGA 點做 technology mapping。咁啱啱都講咗啦。其實 technology mapping咧，其實用FPGA 裏邊咧，就用 LUT 嚟做。見到右邊嗰兩本咧，就係教呢個 LUT 係點樣做 synthesis 嘅。咁如果有興趣嘅人咧，就可以去到讀下。咁其實 LUT 咧，佢個特點就可以一個穿一個，一個穿一個，一個穿一個嘅。因為每一個 LUT 咧，佢可以 support 嘅 number of input 都有限嘅，我哋叫做 K input， 即係 support 到 K 咁多嘅 input。如果你嗰個 logic 係好複雜嘅，有10個 input 或者40個 input，佢就唔可以收落一個 LUT 度嘅。咁所以咧，你喺個 FPGA 度咧，你就要有個技巧，佢做 technology mapping 咧，就即係等於將成個你個 logic 去到逼單咗放落去唔同嘅 LUT 度。你見到左邊咧，佢有個 logic 啦，有好多機啦。但係我每一個 LUT 咧都 support 都淨係得一個 free LUT，即係每個 LUT 淨係得3個 input。咁我點樣先至可以將佢放得落去咧？我就要將個 level 打散。咁打散咧，其實有好多 algorithm 嘅，譬如最左邊嗰個打散咧就係數 input。譬如你逼到每一個嘅 component，即係每一楷得3個 input 嘅時候，你咪可以塞到落去咯。咁咧 FPGA 嘅廠商咧，佢就要喺效能同埋嗰個 area 度做取捨。咁你可能會問，我出一個 LUT 有100個 input，我咪載到晒所有嘅 component 咯，係咪？其實咧呢個你可以話係，亦都可以話唔係嘅。如果你出一個 LUT 好多腳嘅話，冇錯，你好容易載到所有嘅 component。但係如果去到一啲簡單嘅 logic 嘅時候咧，你就會嘥咗好多位。咁所以嘥位同速度同 area 咧係冇兼顧嘅，即係唔可以3樣兼得嘅。譬如右邊嗰個就係咩意思咧？就係話，譬如假設你有個 LUT 係 4 input 嘅，我點樣先可以將幅圖去到逼到 4 input 咧？其實就可以喺度圈啲腳啦，每一個圈都淨係得4隻腳，咁你咪可以一個4 input 嘅 LUT。咁呢個咧就睇多先啦。咁咧而家就好簡單咁介紹咗 FPGA 啦，點樣玩啦。咁其實我哋條 team 咧就同澳洲墨爾本理工大學咧就合作。遲啲就諗住咧，佢哋就會投資我哋去到做粒 FPGA 出嚟嘅，但係就要等我哋個 RISC-V 嘅 project 成功咗先啦。咁如果有興趣咧，你可以就而家 join 我哋條 team 啦。咁我哋條 team 就好 solid 嘅，我哋份就關噏，即係我哋就唔會用人哋嘅嘢啦。我主要咧就係會自己做啦，務求喺個基礎技術嗰度掌握到啦。咁呢一個咧就係我哋想做到嘅嘢。咁我想問下咁多位同學有冇啲問題想問咧？喺 FPGA 上邊有咩問題想問？好，如果有問題咧，之後咧就可以 send 喺呢個 email 度問我啦。咁如果冇問題咧，咁我哋咧呢個 webinar 就好啦。好多謝晒大家。
Thank you Peter，係咪去到呢度就完？多謝大家參與，拜拜。